In this video, we're going to be talking about the physics behind our mousetrap car.
So this is our mousetrap car, and in it we used wood, Lego pieces, which has 4 wheels, kite string, and then the mousetrap. We used tires from Legos to reduce resistance from the ground so it will not slip or spin out. And although things like CDs may have less resistance, our wheels have better traction. This is because they are rubber and obtain adequate traction because they grip the ground well and they give our car potential to have a greater acceleration. We also tried to make all 4 of our wheels large to cover more distance per rotation, and we also have a large wheel to axle ratio to cover more distance each time it turns. Our axles can rotate freely with nearly no friction because of the hollowed Lego pieces that surround them.
Our car has a medium-sized lever because it should be large but not too large. The longer the lever, the less the pulling force, but it will pull more string from the drive axle to go further, so that is why we chose a medium length. A longer lever will decrease the power output by slowing the vehicle down and wasting less energy. Therefore, for long distance, it is best to have a long lever to decrease power output.
According to Newton's first law, an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an unbalanced force. The unbalanced force that causes it not to remain at rest is the spring in the mousetrap when it is pulled back. Friction in the ground is our other unbalanced force when it is in motion, and because of that, we want the car to continue moving, we must minimize friction. According to Newton's second law, force is equal to mass times acceleration. Because our force will always be approximately the same because the mousetrap cannot be altered, it is best to have a lighter vehicle because then acceleration is greater. This is why we chose to make a smaller vehicle with light material. Newton's third law states that for every action there is an equal and opposite reaction. This is why tension is built up in the opposite direction so that as it is released, the car will be propelled forward.
The mousetrap spring holds a lot of elastic potential energy as it winds back, which is then turned into kinetic energy that gets transferred to the lever. The kinetic energy of the lever then gets transferred to our kite string, which turns into rotational kinetic energy that turns the axle and wheels. We want to maximize the energy efficiency so that the least energy is lost, so it goes a greater distance. This and the force being higher will increase the work done. Thanks for watching!